Hi everyone, in this video we are going to discuss what coterminal angles are. Alright, so here we go. I have a circle that is centered at the origin, and we have something called the initial side here, and let's go ahead and label that just so you know what that is. This is called the initial side. Initial side. Alright, and just a little bit more terminology here. The center, the origin, is called the vertex. And what we're going to end up doing is we're going to rotate around the vertex. The initial side is going to rotate around. So let's go ahead and label that. So I'm going to show this rotation. So imagine this guy sliding around, or rotating around, I should say. And then say it ends up right here. Let's go ahead and label that. And so when this thing rotates, it's gonna rotate by some kind of angle. We can call it theta or whatever, but it's some kind of angle. But ultimately, this guy right here is called the terminal side. So I'm gonna say terminal side. Terminal side. Okay, so we have the initial side. We're going to rotate by the vertex, around the vertex, and we're gonna end up at our terminal side. Okay, and so these are some of our vocab words, and what we're gonna do is we're gonna do this in both degrees in this rotation, in degrees and in radians as well. So I'm gonna show you examples of this. Okay, and I guess what I should do before I show an example is, say I rotate around, whatever this happens to be, this angle, and I end up at this terminal side. Well, what if I rotated around again by a different angle? Actually, let's do it this way. Let's go, what if I rotated by a negative amount? If I rotated a negative amount, but then I ended up a negative angle, and I ended up at the exact same location as the other amount, then these angles would be called coterminal. Okay, and it doesn't really matter. I could have another rotation where I went all the way around and past this, and then more than 360, and then ended up again back at the exact same terminal side, then again these would be coterminal. So let's provide some examples of what I mean by this. So I'm going to draw some very basic, let's see here, how do I want to do this? So I'm going to go ahead and draw a little Cartesian plane here, and many times I won't even have like the circle or anything to reference it, and you don't have to, by the way. You just have to know that we always start at the initial side. So let's pick an angle here. So let's pick, like, let's say 45 degrees. Okay, and so if I start here at 0 degrees, and then I rotate around, and this would be approximately 45 degrees. Okay, and so I want to list some angles that are coterminal to 45 degrees. So for example, let's go ahead and rotate by not 45 degrees, but let's go around 360 degrees, all the way around 90, 180, 180, 270, 360 degrees. And then just a little bit more, another 45 degrees. Well, what is that? That's 360 plus 45. That is 405 degrees. So actually, since these end up on the exact same terminal, right? 45 degrees and 405 degrees are coterminal. Let's see if we can come up with another angle that is coterminal to this. And let's go the opposite direction this time. We always start at the initial side. And let's go this way. So I'm going to start, and I'm going to go negative this time. I'm going to go the opposite way. And you can go negative degrees, and you're just going clockwise at that point in time. And let's say I went, what is that, 270, so 315 degrees. So this thing is, I'm sorry, it's negative 315 degrees. Well, if I go negative 315 degrees, I end up again on the exact same terminal side. So I could say negative 315 degrees is also coterminal. And so you might be recognizing a pattern here. So let's go ahead and check this out. The original was 45 degrees, and if I added 360 degrees or one full rotation, right, then I got back to where I started. And if I subtracted 360 degrees, again, I got back to where I started. So let's bring up the calculator here, clear this out. Actually, let me go ahead and load this thing in again. How do I load this? Reset calculator. Is that going to work? Or maybe I have to turn it on. There we go. Okay, perfect. All right, so let me slide this over a little bit. And so what I want to do is I want to figure out, well, what are, like, let's say all of the coterminal or all the angles that are coterminal with what we started at 45 degrees. So I can simply say 45, and I could add, oops, I guess I can't do that on my keyboard. Hang on one second. Yeah, so I can say 45, and then I want to add 360 degrees, and I'll hit enter. And there's your 405 degrees. Well, what if I went around another 360 degrees, right? Let's add another 360 degrees. Well, that's 765 degrees. So 765 degrees is also coterminal. And if I added another 360 degrees, then 1125 degrees is also coterminal. These all end up at the exact same location on the terminal side. Okay, and you can keep going. So the answer to how many are there? Well, there's an infinite number. And I could do the exact same thing. I could clear this out, and I could go the opposite direction. I could say 45 minus 360 degrees, one full rotation, right? And I end up back where I started, which is that negative 315 degrees that we figured out. Then I'm going to subtract off another 360 degrees, another full rotation. So negative 760 or 675 is also coterminal, and I can just keep hitting enter here. Negative 1035 degrees is coterminal, and so on and so forth. Okay, so I can keep going around and around and around, and I always end up back where I started once I do one full turn. In degrees, that full turn is 360, whether I'm going positive 360, which is counterclockwise, or negative 360, which is clockwise. Okay? All right, let's do the exact same thing, and let me go ahead and get rid of that. And let's do another example, a quick one. And this one is going to be, whoops. Sorry about that. This one, we're going to do this one in radians, okay? So here we go. Let me grab my brush, and let's go ahead and grab a color here. So let's go ahead, and we're going to do, I don't know, radians is usually a little bit more difficult. Let's do pi over 3 radians. Pi over 3, okay? So what is pi over 3 radians? Well, that's actually about 60 degrees, so that is right around here. So if I go to pi over 3 radians, let's call that somewhere around here. Okay? And we'll call this pi over 3. All right, perfect. So the question is, what are some of the coterminal angles in radians with pi over 3? Okay, so let's think about that. What is one full rotation? Let's go ahead and draw this out. So I'm going to do one full rotation. So go all the way around. And that one full rotation is 2 pi plus an additional pi over 3. So what is that? Well, we're going to have to do a little bit of math over here. So if I do 2 pi plus pi over 3, then I am going to multiply this top and bottom by 3 here. So that's 6 pi over 3 plus pi over 3, which is equal to 7 pi over 3. So 7 pi over 3 is coterminal with pi over 3. Let's go the opposite direction. And then we're going to use the calculator to help us out after that. So the opposite direction, I'm going to start at the initial side. And now I'm going to go around in a negative manner to get to the same pi over 3. So in this case, it's actually, how do I want to do this? It's actually going to be, it's going to be pi over 3 and then minus, let's do this. It's going to be the negative version of 2 pi. Let's do it down here. 2 pi minus pi over 3. So I'm going to subtract off pi over 3 because that's how much I'm traveling, but it's going to be the negative version of that. So I just have to make sure that I convert this to a negative. But anyway, so when I subtract, it's kind of interesting because I multiply top and bottom by the same amounts, right? So that is going to be multiplied by 3 over 3. So that is 6 pi over 3 minus pi over 3, which is equal to 5 pi over 3. And you have to be very careful, though. This is the negative version. So it is, because we're going clockwise in this case. So this is going to be negative 5 pi over 3. All right, now let's go ahead and see if we can use our calculator to help us out with this, okay? And I'm going to use a little bit of math frac in here as well. So in this case, I want pi over 3. Now I'm going to disregard the pi because remember, pi's are always in your radians. They're always there. So what I'm going to do is I'm just going to use the fractions, okay? So I started with 1/3 pi. So I'm just going to put in 1/3. So let's go ahead and do that. So 1 divided by 3. And actually, now that I'm using this old calculator here, so 1 divided by 3, I have to make sure I put in my parentheses. And so what does it mean to do one full rotation, right? Well, that in radians is 2 pi. In degrees, it's 360 degrees. In radians, it's 2 pi. So I'm going to go ahead and add on, and I'm going to show you a little trick here. If I just hit enter, that's 1/3, then I can just hit plus, and it'll do answer plus, and then I'm going to say, well, plus 2 pi, or just plus 2. That's really all it is plus 2. Now this gives me some kind of decimal here, but if you do math frac, then there you go. So I get 7/3, which, remember, you got to throw your pi back in there. Now, if I go ahead and say second entry, which was the previous answer plus 2, hit enter, now I get 13/3. Okay, so 13 pi over 3 is also coterminal. All right, and I can continue doing this, right? 19 over 3, 25 over 3. These are all coterminal. 31 pi over 3. This is coterminal with 1/3 pi. Let's go with the opposite direction again. So I'm going to do 1 divided by 3, hit enter for 1/3 pi, or pi over 3. And now I'm going to subtract off. I'm going to go the opposite direction by a full rotation of 2 pi. So I'm going to subtract 2. And I'm going to do a math frac. And there we go. So there's your negative 5/3 pi, negative 5 pi over 3. And then I'm going to do the same thing. I'm going to go to second entry and the previous one in that, second entry. And there we go. So the next one, if I'm going the opposite direction, would be negative 11 pi over 3. Next one would be negative 17 pi over 3, and so on and so forth. All right. So there we go. You just saw 2 different examples. This second one was in radians. And basically, what does it mean to be coterminal? Again, it means you end up, whether you're going clockwise or counterclockwise, you end up at the exact same location. All right, and we also did our degrees, which was identical. Instead of adding and subtracting 2 pi with degrees, you're going to add and subtract your 360 degrees. All right, so there we go. That's all about coterminal angles.